It's me, Mr. Cardone. We are at the next method for our handy dandy factoring guide. This method is what we call difference of squares, okay? When can we use it? Well, has to be a binomial. Has to be separate. Oh, and we look at our example that we're going to do, binomial one term, two term, okay? Has to be separated by subtraction, hence the name difference. Difference of squares. Doesn't difference mean subtraction? It certainly does. So this is subtraction, and maybe the harder part to pick up on is they both have to be perfect squares. Well, x squared is a perfect square, and the reason being is the square root of x squared is x. The square 81 is a perfect square because the square root of 81 is 9. It would be a perfect square if when you take the square root of it, there's nothing left of the radical. Like 5. Is 5 a perfect square? Nah, I don't think so. What about 36? Is 36 a perfect square? Yeah. What about x to the fourth? Is that a perfect square? Yeah, because the square root of x to the fourth is x squared. What about x to the fifth? I don't think so. We'll talk about this a little bit, identifying perfect squares. I'm going to push pause and we'll talk about it. And we're back. All right, so we've identified it's a binomial. It's subtraction. And both terms are perfect squares. Well, it's really easy. Anytime you have difference of squares, it's always going to factor into two binomials, all right? The signs for the factors, for what's separating the two terms in each of the factors is always going to be plus and minus, always. For difference of squares, it's always plus and minus. And then the first term in each factor is going to be the square root of the first term. So what's the square root of x squared? X. And then x here as well. And the second term of each of these factors is going to be the square root of the second term. So what's the square root of 81? It would be 9 and 9. So x squared minus 81 factors to x plus 9 and x minus 9. Now the fun fact, it's the easiest method of all of our types of factoring, okay? It's really super easy, difference of squares. Because it is so easy, let's try one more. Let's try a real difficult one. Let's see how challenging I can make it. 4x to the fourth minus, let's do 9y squared z to the sixth. I don't think I can make it any more difficult than that. So is 4 a perfect square? Yeah. What about x to the fourth? Yeah. What about 9y squared z to the sixth? Yeah. Yeah, those are perfect squares. So this is going to factor into two binomials, right? One of them is going to be plus, one of them is going to be minus. Someone tell me what 4x to the fourth square root is. Did somebody say 2x squared? So that's going to go here in this first factor for the first term, and then the same 2x squared here. Now what's the square root of 9y squared z to the sixth? Take it step by step. First 9. What's the square root of 9? Yep, 3. What's the square root of y squared? Yep, y. And what's the square root of z to the sixth? Z cubed. So, I hope you can read this. This is my 19th video of the day, so I'm getting tired. I hope you can read it. But 2x squared plus 3yz cubed, 2x squared minus 3yz cubed. And that's how you factor using difference of squares. And that's it for difference of squares. I will see you in the next one. There's a few more types to go through. Look forward to it. Have a wonderful, that's all I'm going to record today. But you all have a wonderful day. We'll continue this next time.